For part A, to multiply these two expressions, we have to distribute each term into the other set of parentheses. So to start with, we're going to multiply the x to the x and the x to the 4, which gives us, well, x times x is x squared, and x times 4 is plus 4x. We then repeat this process with the other term, which is the 1, that multiplies to x and 4 again, and this time we get plus x plus 4. The last thing to do is to combine all like terms to get our final answer, and that is x squared plus 5x plus 4. So this is going to be the same idea for the remaining parts in this practice. So for part B, we're going to start with distributing the 2x. When we do, we get 6x squared minus 2x. We then repeat this process with the 3. This gives us plus 9x minus 3. And when we combine like terms, we get 6x squared plus 7x minus 3. All right, for the part C, same idea, but now there's 3 terms in the second set of parentheses, but we approach it the same way where, okay, 3x gets multiplied to 1, the 2x, and also the 3x squared. So this gives us, okay, we get 3x minus 6x squared plus 9x to the third power. I then repeat this now with the negative 4. Again, that gets multiplied to those 3 terms. I'm going to run out of room, so I'm going to place this below a little bit. We get negative 4 plus 8x minus 12x squared. And the last step, again, is just to simply combine the like terms. So I notice the highest power is this 9x cubed. I'm going to go ahead and write that down first. That's 9x cubed. Okay, next, I guess, would be the x squareds. I see there's one here and here. Negative 6 and negative 12 gives me a negative 18x squared. I then can combine the x's. There's 3 and 8 here for a total of 11. And the last thing that we haven't done is use this 4. It's the only number, so that means we just get a minus 4 at the end. Okay, so let's now look at part D. Same idea. I'm going to multiply the 1, the x, and the x squared into all 3 terms in the parentheses. So I'll try to draw lines for this. It could get a little messy, but I'm multiplying the 1. And that's really easy when we multiply in 1. That just gives you 1 plus x squared. I now multiply in the x. All right, how am I going to fit that in? That'll be, so the x gets multiplied to the 1. It gets multiplied to the x as well as the x squared. So this time we get x times 1 is x times x is x squared, and x times x squared is x cubed. And lastly, I multiply in the x squared to those 3 terms. So this time we get x squared, an x cubed, and an x to the 4th. So I purposefully lined it up this time so I can just add all the like terms together. There's only one 1. There are 2 x's. There are 3 x squareds. There are 2 x cubed, and only 1 x to the 4th. And that's my final answer. For parts E and F, so here we have something squared, which does not mean square the x and square the 4. It means copy down the thing in parentheses twice. So I'm going to rewrite the problem. This is really saying multiply x plus 4 times x plus 4. So being careful, I multiply in the x. When I do, I get x squared plus 4x. Second step will be to multiply in the 4. When I do, I get a 4x and a 16. And after combining all of my like terms, there's only 1x squared. There are 8 x's and then 16 at the very end. One interesting thing to point out is that when you square an expression like this, I mean, you do end up with the first term squared, x squared. and you also end up with the last term squared, which is positive 16. But the difference is you end up with double what you have in the middle here. So this 4 doubles to go to an 8. And the reason is you get two 4x's which add together. This will always be true for an expression like this. So you could use this idea on multiplying this thing together. I mean, I'll put what I think the answer is going to be at the very end, kind of like jumping ahead. Like if you were to square this out like we did up here, you would definitely get an x squared. Negative 5 times negative 5 is a positive 25, so you get a positive 25. But in the middle, you get a negative 5x, and you get a second one, which means you double it to negative 10x. Like, I think that's what the final answer is going to be. I just want to verify it with the process we've been doing in this problem. So by that I mean x minus 5 squared is x minus 5 times x minus 5. If you multiply in the x, you do again get that x squared, but you also get a negative 5x. When you multiply in the negative 5, you get another negative 5x, but now this is where you get that positive 25. And no surprise here, when you combine all the like terms together, you do get that x squared. There is that positive 25 at the very end, but we're doubling that negative 5 for the middle term. So problem 1 was multiplying. Question 2 is going to be dividing, so the inverse of that process. So here I want to divide x plus 1 into 2x squared plus 7x plus 5. I'm going to set this up using the division algorithm. That is, I have x plus 1, and I'm dividing that into 2x squared plus 7x plus 5. I want to cancel as much of this 2x squared as possible, so I have to make a choice. What do I multiply x by to get a 2x squared? And the answer is you need a 2 and also an x. I'm going to put that above the x's. So for my first choice, I have 2x. This 2x gets multiplied to this whole expression, so you multiply it to the x, giving you a 2x squared. And then you multiply this 2x to the 1, which gives you a 2x. I'll put that below the x's. I want to subtract this from what is above it. That's 2x squared minus 2x squared, which is 0. That's exactly what we want. We're going to have some stuff left over here. That's 7x minus 2x to give us a total of 5x. I then bring down the 5 and repeat this process. What I want to do is now cancel as much of this 5x as possible by multiplying something to x plus 1. And the answer is 5. So I'll put that here. And this is going to work out perfectly because 5 multiplied to x is 5x, and 5 multiplied to 1 is 5. So that is 5x plus 5. And when I subtract this whole thing, this is 5x minus 5x, which is 0. I have 5 minus 5, which is also 0. And that means I have a remainder of 0. All right, let's check out part B. Same idea. Okay, I want to divide x minus 1 into 4x squared minus 5x plus 1. So step 1, I want to cancel a 4x squared by multiplying something to x. And the answer is I'm going to multiply by 4x this time because you get 4x squared and also minus 4x. And I'm subtracting this thing. And for the first part, it's pretty simple. 4x squared minus 4x squared is 0. I'm not going to write anything, but here's where you have to be careful. 5x, a minus is really, you're adding 4x to negative 5x. So negative 5x plus 4x is going to be negative x. And then I'll bring down the 1. Okay, so the goal is I want a negative x down here. And I have to multiply x by something to get a negative x. And there's only one choice that works out perfectly, and that is multiply it by negative 1. negative 1 times x is negative x. And negative 1 times negative 1 is positive 1. So we get negative x plus 1. And we are subtracting this from the terms above it. So this is negative x. Well, minus a minus is really plus x. Negative x plus x is 0. We don't have to write it. Then I have 1, really minus 1. I do have to put a 0 in to represent that something happened, but that, again, is my remainder. All right, let's check out part C. For this problem, x minus 2 is being divided into something that has an exponent of 3 in here. So I have an x cubed. I see there's no x squared, but I still want to somehow represent a location for dealing with the x squareds. I think that's going to be helpful for us. So I'm going to put in x cubed. I'm going to put 0x squared and then minus x minus 6. The reason I'm putting this here is so I have a placeholder. So if like some x squared show up in the problem, I have something to write it below. Okay, so step 1 is the same. I want to cancel x cubed by multiplying x by something, and that thing is going to be x squared. So it's actually a good thing that I placed this here because I'm going to put the x squared above it. And then I multiply this x squared to the x, which gives me my x cubed. But then I have x squared times negative 2, which gives me negative 2x squared. So that is x cubed minus 2x squared. And I am subtracting this. So again, we have the x cubed minus x cubed is 0. Now here, 0x squared plus 2x squared is going to be positive 2x squared, and I bring down the x. Okay, so I now want to cancel a 2x squared. So I'm going to multiply x by 2x. That's going to be my next choice. So I have plus 2x. 2x times x gives me my 2x squared. Now 2x times a negative 2 gives me a negative 4. All right, so we get 2x squared minus 4x. And I want to subtract this. So it's good that we have 2x squared minus 2x squared, but here we have negative x plus 4x is 3x. I'll bring down the negative 6, and let's repeat this process. Okay, I now want to cancel a 3x, which means I must multiply this x by 3. Okay, so I'll put plus 3 at the end. When multiplied to x minus 2, I get 3x minus 6. Just like in the previous problems, when I subtract these, since they're exactly the same, it gives you a remainder of 0. All right, last one. I want to divide x minus 5 into 6x squared plus 11x minus 7. All right, so for this, I guess my first choice will be multiply by 6x because we get 6x squared minus 30x. And when I subtract this, okay, I get, but the 6x squared is canceled, but now I have 11x plus 30x, which is 41x, bring down the 7. And I'm at my last step, and this is different. Like, all the remainders before were 0. I don't think it's going to work out perfectly this time. I mean, my next step has to be to cancel the x's, so I am multiplying by 41. You do get 41x, but you also get negative 205. And I'm subtracting this. So this is really, well, the 41x's do cancel, but it's going to be negative 7 plus 205, which is 198. So that means we actually wound up with a remainder in this problem. But this is how you would divide it, even though the remainder was not 0.